In this video, I'll talk about inserting new node at the given position of a linked list, okay, linear linked list. This is a definition of the node. The node contains one information field and the address field. This is the constructor, and this is the method which will return the value of the data stored within the node, okay. Now, this is the class linked list. It has some member variables like head, move, temp. These are all of type node. This is the constructor. Here the method to insert node at the end of the linked list. Okay, now I will write the method to insert node at given position. Okay, so let's suppose we have a node like this. Okay, so this is the first node, head. There is 17, then there is 15, 18, 20, then 5. Look, this is the last node. Now we want to insert a new node after this node. Okay, first, second, third. We have to insert new node after third node. So we have to take position as the input, and we'll be providing new node that to be inserted within the linked list. Okay, now let's write the method public void insert at, okay, let's make it clear, insert at, now integer position, then node t. Okay, what we have to do is we have to create a loop I for I equal to 1, I less than position I plus plus. Okay, now we have to insert new node after third node, first, second, third. Okay, third. So this loop will run from 1 to 2. Okay, 1 to 2. So what we have to do, one more thing is we have to get reference of the head here. We will assign temp is equal to head. Here we can see temp is the member variable, head is the member variable of this linked list class. I'm continuing the definition of this linked list here. Okay, so I'm assigning head to the temp. Now we have to make temp up to here. Our temp should reach up to here. Okay, so how many times we have to iterate is initially temp is head, then we have to do one more next. Okay, so I will be writing temp is equal to temp dot next. Now what will happen here is initially temp is head. Okay, this is temp, then our loop will start 1. Here the position provided is 3. After the third position we want to insert, so I is 1, 1 is less than 3, that is true, so this will be executed. Now our temp will move to this position. Okay, after this our temp will reach here, then our I will be incremented, it will become 2, 2 is less than 3, again temp will be moved. Okay, now our temp will be here. Simple. We are doing temp equal to temp of next. Here this is the temp initially, and this next is containing a reference of this node, and so that means as we do temp is equal to temp of next, temp will come here. Okay, then after as temp reached here, if we do temp is equal to temp of next, in the temp of next we are having address of this node, so temp will point to this node. Now out I will be incremented and it will become 3. Okay, now 3 is less than 3, that is false, so we are out of the loop. Now what are we supposed to do here is we will do, this is the new node we have to insert. T dot next is equal to temp dot next. Now what is there in the temp dot next? This is the temp, so in the next of this temp we are having reference of this node. Okay, this is the temp dot next. Okay, this is the temp dot next. Okay, so t dot next. Now suppose I will write a small one. Our new node is this, and this is t. Now t dot next we are assigned temp of next. That means we will get the reference of this node in this position. Okay, t dot next equal to temp of next. Now what we do is temp dot next is equal to t. Now what will happen? This is our temp. Now temp of next, what we are doing? We are assigning, now this is connected, we are assigning t to the t dot next. Now this is our t, so we will assign this to this position. This will be overwritten. Now in this way we are able to connect this t to the next of this node, and this node is connected to the next of this t. That means this new node will be inserted between 18 and 20, it means third and fourth position. Okay, so in this way we can insert new node after the given position. Okay, this is a very simple one. This is the benefit of the linked list over the array. In array it will be time consuming process to insert element at given position, because we may have to do lots of shifting of the element in order to make vacant space within the array. But in case of the linked list, it is very easy. Just we have to know where we have to insert, and just we have to switch some pointers, some references. Okay, so in this way we can insert new node after a given position. Okay, now let's see how to remove node of the linked list of given position. Okay, suppose this is the linked list, and we want to delete this node. Okay, 1 2 3 4, the fourth node we want to delete. So what we have to do is we have to get the reference of this node. Okay, we have to get the reference of this node. So for this we will be using the iterative statement. Okay, now let's write the method. Okay, public void delete at. Now we have to take the position as parameter. Now let's assign head to the temp. Then we have to declare one integer variable I. Then for I is equal to 1, I less than position. Okay, I'm leaving some space here. I plus plus. Now let's do temp is equal to temp dot next. Then let's see what happens. Now initially the value of I is 1. Okay, so initially the value of I is 1. So position is 4. 1 is less than 4. We are passing 4 here. Okay, so this condition evaluates to true. Initially temp is this one, because this is statement here it is assigned to the temp. Now I is less than 4 will be taken inside the body of the for, so temp will become temp of next. So our temp will move here. Okay, as we do, temp is equal to temp of next. Then this will be incremented by 2. Then this will become 2. 2 is less than 4. Again, that is true. Now temp will move here. Temp will reach here. Okay, now we wanted the reference to this node. That means now our iteration should stop here now. So what we have to do, we have to deduct 1 here. Now this will become 3. Now I will be incremented and it will become 3. 3 is less than 3, that is false. So we are out of the loop. Now our temp has reached here. Now what we do here is just simply we have to store reference of this node to this position, this address part. Okay, so what we do? Okay, let's assign this temp to this node is equal to t is equal to temp dot next. Let's assign this one. This means now this is our t, because this is the temp. We are assigning temp of next to the t, so this is t. Now we do here is t temp dot next is equal to t dot next. Now this is t, so t dot next contains reference of this node. T dot next, this is the t dot next. Okay, this is t dot next, it is containing reference of this one. Okay, we are assigning this reference to temp.next. We can see here temp.next is equal to t.next. So this t.next, this is the reference of this node is assigned here. So the link between this node is gone. Okay, now there is no link between this node and this node, because this address, whatever previously contained in this address part, was overwritten with this reference. Now what we do is we write t is equal to null. Simple. So that means this no. Now this will not refer to anything. Okay. So now this and this these two nodes are connected. Means the fourth node is deleted. Okay. Using this very simple logic, we can delete node at the given position also. Okay. This is a very simple one. Okay. So in this way, we can add new node at given position or after the given position, or we can delete node of our linked list of specified position in this way. Okay. Thank you very much for watching. Thank you very much.